Welcome back to 5-Minute Chemistry. Today we are going to discuss the mass of atoms and the concept of molecules. So, how much does actually an atom weigh? Is not really an easy question to answer, especially not in the 19th century, but it was possible to compare the masses of atoms to each other, which was the concept of relative atomic mass, or at the time it was called relative atomic weight, and this is denoted by this capital A and the lowercase r in the bottom right index. And based on the different masses of the atoms, in compounds we will have this very strange kind of arbitrary mass ratios. So like in water, it's 1 to 8 between hydrogen and oxygen, and carbon dioxide, it's C2O in 1 to 2.67. But we know from Dalton's atomic theory that these compounds are actually made up of elements in relatively small whole number fractions, but because they weigh different, the atoms have different weights, therefore the weight composition will not be those very simple numbers. And the law of multiple proportions even complicates the thing further for us, because we can have multiple compounds which have different atomic compositions, and and sometimes that can confuse us when calculating the relative atomic weights. So let's consider the compounds made up of carbon and oxygen. So in one of them we have carbon to oxygen mass ratio 1 to 1.333, and in the other we have 1 to 2.667. So if we assume that the first one, the atomic ratio is 1 to 1, and in the second one, for every one carbon atom we have 2 oxygen atoms, then the relative weight of these two atoms will be 1 to 1.333. But if we assume that the second one is the one where we have the atoms at 1 to 1 ratio, and the first one we have 2 carbon atoms for every 1 hydrogen atom, then we would have different relative atomic masses for these two atoms. So luckily, an Italian chemist called Avogadro came up with an interesting idea concerning gases. So by this time, chemists knew that every material is made up of particles called atoms. Physicists were still arguing about that. But Avogadro came up with this law that there is a direct proportional relationship between the volume of a gas and the number of particles in a gas at constant temperature and pressure. And that means that the volume only depends on the number of particles the gas is made up of, and it is independent of the type of those particles. There are a few other properties of gases that are like this, but that were used in determining the relative atomic masses. But here we will go with Avogadro's law for the sake of simplicity. So that means that the mass of a gas will be determined by the number of particles and the mass of the particles it is made up of. So if we have the same volume at constant pressure and constant temperature of two different materials, then the mass ratio between them will be the mass ratio of their particles. So in oxygen and hydrogen case, for example, the oxygen gas will be 16 times heavier than the hydrogen gas. So we can deduce that the particles in the oxygen gas will be 16 times heavier than in the hydrogen gas. And this can help us understand compounds, especially in gas form. So if we form water vapor from oxygen and hydrogen gases, then by volume we'll have to mix 2 liters of hydrogen to every 1 liter of oxygen to get, in the end, 2 liter water vapor from this, which is kind of interesting. First of all, we can see that there are 2 times as much hydrogen by volume, or by particle in this case, because of Avogadro's law in water, than by oxygen. So based on the mass ratio, we can deduce the relative atomic masses of these two atoms relative to each other. But there is also a very strange thing here. So if we say that 1 unit of oxygen will make 2 units of water, that is kind of impossible, because that would mean that 1 oxygen atom has to be cut in half to go into 2 different particles of water, which is impossible based on Dalton's atomic theory. Atoms cannot be subdivided. And similarly, we will have the same problem with carbon and oxygen. If we can form one of the type of the gases, in the first case, we will have, for every 1 liter of oxygen that we put into this reaction, we will get 2 liters of this first type of carbon oxide, while for the other type of carbon oxide, we will have 1 liter of this gas for every liter of oxygen gas that we used up. So based on this, we can deduce a few things, not just that in one of them there are twice as many oxygen relative to carbon, but we can also deduce that oxygen seems to exist as a diatomic gas. So we can halve whatever is in the oxygen gas, because actually oxygen does not exist as independently moving atoms. Actually, 2 atoms are stuck together and they move together. So this means that atoms in elements can be bonded together. So atoms don't just bond to other atoms to form compounds, they can also bond together with themselves. And so oxygen, nitrogen, hydrogen, for example, these were found to be diatomic gases, while argon was found to be monoatomic. So in conclusion, Avogadro came up with this concept of molecules. So while Dalton's atomic theory postulates that atoms are the smallest particles a matter can be divided into, Avogadro said that molecule is the smallest particle a material can be divided into while preserving its chemical characteristics. So in case of water, by Dalton's theory, you can divide water into atoms, so you can get the hydrogen atom and the oxygen atom, but now you destroyed water's chemical properties, while in a molecule, you just stop at the point when it still has the chemical properties. And this goes also with elements and also with compounds. Okay, so this was for today, and I will see you tomorrow.